angle measure. First thing we're going to talk about here is what is a coterminal? What is a coterminal? Given any angle, a coterminal given any angle t, a coterminal is an angle other than t that brings you back to the same place as t. That brings you back to the same place as angle t. What does that mean? So we have our xy axes, and angle t is that amount. That is angle t. What is another angle that can bring us back to angle t? The answer is you can take angle t and add 360 or 2 pi. That brings you back to angle t. Or you can add 360 twice. That brings you back to angle t. Or you can add 360 again. That brings you back to angle t. As long as you get back to angle t, it's the same. Now, since I drew on this a bit, let us try to draw the same thing, same angle. That is angle t. Now, you can go to angle t, and then you can go back 360. That brings you back to this line. Or, once again, you can go to angle t and go back 360 and go back another 360. That's going to bring you back to t. You can go back another 360. Going 360, positive 360 or negative 360, is going to bring you back to the same place. So basically, you can take angle t and add or subtract any multiple of 360 you like, except 0. If you take angle t and you add 0 times 360, you're gonna get back t. And it won't be a coterminal, because a coterminal is an angle other than t that brings you back to the same place. So you just can't add 0 times 360. You can add 9 times 360. You can add 33 times 360. You can add negative 12 times 360. It has to be an integer multiple of 360, but not the 0 multiple. So here we want to find 2 positive and 2 negative coterminals for the given angle. So if I give you 60 degrees, find 2 positive ones and 2 negatives. Well, I can add 360. That gives me 420. That's one positive answer. I can add another 360, and that gives me 780. That's another positive one. I mean, if I chose, I could not have used this one and add another 360 and get 1140. Okay, now if you have 60 degrees and you take away 360, you'll be at negative 300. That's one of the negatives, coterminals for 60. I can take away another 360. That means I'll be at negative 660. That's another one. Those are the two easiest ones. Again, maybe I don't use this one or that one, but I take away another 360, and it looks like I'll get negative 1020. So instead of one of these, I can have negative 1020. But that's more work. So these are two positive and two negative coterminals for 60 degrees. Now, what if we played the same game for 1460? Okay, what do I get for 1460? Well, I can take away 360 and I get 1100. Oh, that's a positive coterminal. I can take away another 360. That gives me 740. That's another positive one. Now, I want to take away, so I have my two positives. So I want to take away enough so I get a negative. Well, 360 isn't more than this. I'm going to have to take away more than that to get negative. Another 360, that's 720. That's not more than 740. My goodness. So I'm going to have to take away another 360. I'm going to have to take away 1080. So I take away 1080. If I'm doing my math right, I get negative 340. Negative 340 degrees. And then I take away another 360 and I get negative 700. So unless I made some silly arithmetic error, there are my four answers. All I did was add and subtract multiples of 360. First, I took away 360 once, then I took it away a second time, I got negative 740, and then I took, so those are my two positives, so then I took away enough to get negative, took away 1080, and that gave me negative 340. I took away another 360, that gave me negative 700. Okay. Now, how about this? What if you have 11 pi over 6? Well, that's not more than 2 pi, because 12 over 6 is 2 pi. So the first thing I want to do is add 2 pi. But I'm going to add it that way. I'm going to be smart about it. I'm going to give myself a hand and make sure I have the same denominator. If you don't know what goes on top, so you know what goes on the bottom, 6, and you know you want to get 2. If you don't know what goes on top, just multiply those two numbers. That's what goes on top. Okay, this here gives me 23 pi over 6. And then, once again, so that's one answer. And now I'm going to add another 2 pi, and I get 35 pi over 6. So one answer is 23 pi over 6. The other answer is 35 pi over 6. Now, as I said, 11 pi over 6 is less than 2 pi. So if you take away more, like 2 pi, it'll be negative. In subtraction, if the denominators are the same, keep them. 11 pi minus 12 pi. Well, 11 minus 12 is negative 1. negative 1 pi. That's one negative answer. Negative 1 pi over 6. You have negative 1 pi over 6, and you want to take away 2 pi, which is 12 pi over 6. In subtraction, the denominators are the same. Keep them. Negative 1 minus 12 is negative 13 pi's. That is the second negative that we came up with. Suppose you have negative 15 pi over 2. So what over 2 gives me 2? Because I can only add 2 pi. And the answer is 4. That is 4 pi over 2 is equal to 2 pi. So I can add 4 pi over 2. So let me just write this on the top, so we can record our answers. Negative 15 pi over 2. Well, this is a negative 11 pi over 2. That, of course, is a negative answer. And then I add another 4 pi over 2. Negative 7 plus 4. Negative 11 plus 4 is negative 7 pi over 2. Negative 7 pi over 2. Now, I can add another 4 pi over 2, and I'll get negative 3 pi over 2. Let me just bring that up there. But that's negative. So I'll add, I don't want another negative. I have my 2 negatives, so I'll add another 2 pi, and I'll get, pi over 2. That's good. And then I'll add another 4 pi over 2. 1 pi over 2 plus 4 pi over 2's gives me 5 pi over 2. Now, okay, so when you were at negative 7 pi over 2, maybe you foresaw that if you add 2 pi's, it'll still be negative. So maybe you want to add 4 pi. So what over 2 gives you 4? 2 times 4 is 8. That is 8 pi over 2 gives you 4 pi. So you could have added 8 pi over 2, and you get pi over 2, which we already had. Add another 2 pi, which is 4 pi over 2. That gives you 5 pi over 2. Now, if you go from angle T to angle T plus a let's write the multiple at the end, plus a multiple of 360, that means that the difference between the two angles, the t's cancel, is a multiple of 360. So if two angles differ by a multiple of 360, that is, they differ by 360, 720, 1080, negative 360, negative 720, negative 1080, and so on, including, well, not including 0, because the difference is 0, which is 360 times 0. They're not coterminals. They're only coterminals if they differ by 300, a multiple of 360 degrees. So the question is, are these two angles coterminals? So you subtract the two angles and you get 360, which is a multiple of 360. So yes, that is, those two are coterminals. What if you had negative 20 and 1060? So you subtract. The large is better to do, easier to do the larger number minus the smaller number, and that's 1080. And you have two choices. You can do 360 into 1080, and if you try 3, you'll see it works. Or you can take 1080 and, if you happen to know that 720 is a multiple of 360, you take away 720, then you take away 360 and you get 0. If you didn't know 1080, you can take away 360, you can take away another 360, you can take away another 360. If you get to 0, then they are coterminals. This number is a multiple of 360. What multiple? Well, I took away 360 once, twice, 3 times. Here, I took away 360 2 times, and then one more time, for a total of 3 times. Or, you do the long division, and you get 3 times. How about 5 pi over 2 and pi over 2? Well, you subtract them, and they do have the same denominator. So if you have 5 pi and you take away 1 pi, that's 4 pi, and the 4 over 2 is 2. The difference is a multiple of 2 pi. 2 pi times 1. If you have 9 pi and negative 5 pi, well, the larger minus the smaller, change, that gives you 14 pi, which is a multiple of 2 pi. 7 times 2 pi. So the answer here is yes, they are coterminals. Yes, they are coterminals. Last one. If you have 9 pi and 6 pi, 9 pi minus 6 pi is 3 pi. 3 is not a multiple of 2. Okay, so these are not coterminals. They are not coterminals, because this here is 1.5 times 2 pi, because the 2's would cancel and you'll get 3 pi. The problem is that's not an integer. This here is not an integer multiple of 2 pi. So now, we want to find a coterminal between 0 and 360, or 0 and 2 pi. Find a coterminal between there. So, I give you 750. Now, you have two choices. You can take away 360 one time, and then take it away again, and now we get a number between 0 and 360. That number was too large. Or, if you know your 360 table fairly well, you can take away 720 to get 30 degrees. So that one is done. It's 30 degrees. That's the coterminal between 0 and 360 degrees for 750 degrees. Now what about negative 810 degrees? Now if you like, you can add 360, and I guess it'll be negative 450. You can add another 360. I guess it's going to be 90, and there's your answer. Or you can say, you know what? I know 360 times 3 is 1080. And then you get 270, which is also between 0 and 270. This should be plus first of all. So there's definitely a problem here. Well, let us check this number. If we do 810 minus 360, we do get 450. But since we did it backwards, it's negative. And then if you add another 360, if you do 450 minus 360 is 90. Excuse me, that's negative 90. And if I add 360, then we get 270. So a positive coterminal between 0 and 360 is 270. Again, depending upon how good you are with your 360 table, you might say, well, I can add 720, and this gives me negative 90, and when I add 360, I get 270. So, no matter how we do it, we keep getting 270. Now, what if you have 7 pi? Now that's a little bit easier because we know multiples of 2. So how about we take away 6 pi and we get pi? And that is in between 0 and 2 pi, right? So that's the answer. If you have 7 pi over 2, why, that's 3.5. So if you take away 2 pi, which I'll write that way, you get 3 pi over 2. And again, 3 over 2 is 1.5. So that's between 0 pi and 2 pi. It's 1.5 pi's. If you have 15 pi over 2, that's 7.5 pi's. So we can either take away 2 pi or 4 pi or 6 pi, but not 8 pi. So we want to take away 6 pi, but we want to have a 2 in the bottom because that's a 2. 2 times 6 pi is 12 pi. So I'm going to take away 12 pi over 2. We're subtracting. The denominators are the same, so we keep that denominator. And 15 minus 12 is 3. 3 pi over 2. And we kind of knew that. If you take away 6 from 7.5, you get 1.5 pi. 3 pi over 2. Okay. Now, let us talk about arc lengths. So, here's the center if I give you this piece, this angle, call it T, I want to know how big is that arc. So, and that arc is called S. So let us look at this. Suppose you have the angle, and we'll also talk the arc length. We'll also talk about area, because we like to know what is that area. Well, what we know is if the angle is 2 pi, that is the whole circle, then the arc length is all the way around. That's 2 pi times r. And the area, when the angle is 2 pi, is all of that, which is pi r squared. Now, if I divide by 2 pi, remember, this is 2 pi radians. If I divide by 2 pi, I get 1 radian. I have to divide that by 2 pi, and I get r. And if I divide that by 2 pi, the pi cancels, but the 2 doesn't. That's for 1 radian. That means the following. If that angle is 1 radian, and the radius is r, then S, this arc length is r, and the area is r squared over 2. That's for 1 radian. But I don't want to know about 1 radian. I want to know about an arbitrary number of radians. I multiply by t. So, t radians. Well, I have to multiply by t. I have to multiply by t. In fact, let us say theta. So I multiply the r, I multiply this by theta, I multiply that by theta, and I multiply r squared over 2 by theta. What this tells me is the following. It's not a rigorous proof, but it gets the job done. Guess I didn't need to draw the XY axes, but if you have an angle of theta degrees and the radius is r, then this arc length is going to be r times theta, and the area is going to be r squared over 2 times theta. Okay. So let us keep that chart up there. And now we want to find the arc lengths of the following. We have an angle of pi over 4, and the radius is 4. Now basically we just need the last one. When the angle is theta radians, the arc length is r theta. So this arc length will be r times theta, which is pi. The 4's cancel. That is how long that arc is. Now everything has to be in radians. If I tell you that this is 60 degrees and this is 8, you need to say, well, 60 degrees is 180 divided by 3. So now this arc length is r times theta, which is 8 pi over 3 units. If you were given this, you have 90 degrees and 16 centimeters for the radius. Well, 90 degrees is 180, which is pi, over 2. So the arc length is r times pi over 2 centimeters. It's 8 pi centimeters. That's exactly how long that is. Suppose that you were told that the radius is 5, the arc length is 10, they want you to find theta. Well, you know that S is equal to r theta, so theta is S over r. I divide that by r and I get theta, and I divide that side by r and I get S over r. So it's 10, that's the arc length, divided by the radius, and I get 2. Now, this might be 10 centimeters, and this is 5 centimeters. So the centimeters do cancel out, and I do get 2. And if these were different units, you'd have to make them the same before you do the division. Okay. That's S and A. So, once again, I still like to have the formulas in front of us. Let us now try this problem. Suppose that you are told that that's 2. So since I don't say degrees, it must be radians. And that's 8 inches. Well, we know that S is r theta. Divide both sides by theta, and we have r is S over theta. And if I didn't say it, the instructions is defined r. The only thing that we're not given. So it's 8 inches divided by 2 radians, which is 4 inches. So r is 4 inches. Okay. Here, I'm telling you that the angle is 30 degrees. The radius is 5 meters, and I want you to find the area. Well, the area is simply r squared over 2 times theta, but it must be in radians. 30 degrees is 180 divided by 6. Okay, so I get 5 meters squared over 2 times pi over 6. So the bottom is going to be 12. 5 times 5 is 25 times the pi times meters squared. So it's 25 pi over 2 meters squared. And meters squared makes sense because it's area. Area is always square. Volume is cubed. Let us try one more, please. Suppose you are told that this is 135 degrees and that r is 7 inches. The instructions are to find the area. Well, that is, find this area. Well, we know the formula is r squared over 2 theta. Now, we don't quite have theta because it's in degrees. Well, what you need to realize is that 135 degrees is 45 times 3. And maybe I should have written it as 3 times 45. Now, pi is 180. And if you divide 180 by 4, you get 45. And we have 3 times that. That is, we have 3 pi over 4. Okay, so it's the radius squared over 2 times 3 pi over 4. So you get 7 squared times 3 pi over 8. 2 times 4 is 8 times inch squared. 49 times 3 is 147 pi over 8 inch squared, or square inches. That's exactly what is in here. If you cut out square inches, and of course, since it's circular, you won't find perfect 135. But, you know, this piece here, plus maybe this piece here, etc. Those pieces, when you cut them out and paste them together to make square inches, in their end, you'll have that many. You'd have about that many. Around 50, I would say. Actually, less than 50. And that completes this section on angle measurements.